The James Webb Space Telescope, widely known as JWST, has unveiled an extraordinary and puzzling phenomenon. Instead of the usual cosmic silence, astronomers observed columns of radiant light that seemed to pour outward from a region resembling artificial construction, casting illumination across the void of space several light-years away. Such a discovery has reignited both scientific curiosity and public wonder, reviving the age-old question: could intelligent life exist beyond Earth? When JWST turned its precision instruments toward Proxima Centauri b, the nearest known exoplanet orbiting a star outside our solar system, it detected intense and unusual bursts of light. These dazzling flares were unlike ordinary stellar activity, and they raised a thrilling possibility. Could they be the fingerprints of an advanced extraterrestrial civilization? For now, the mystery remains unsolved, and scientists urge patience as more data is gathered and analyzed. For generations, humankind has been fascinated by the possibility of life among the stars. Even the faintest sign of biology beyond Earth sparks immense excitement, fueling dreams of discovery. This moment feels different. JWST may have captured the first convincing evidence of unusual illumination on a remote world. Patterns that resemble the glow of enormous alien cities stretching across the landscape. If this interpretation proves correct, it could represent a paradigm-shifting moment, one of the greatest scientific breakthroughs in human history. NASA engineers were stunned by the finding, questioning how long such lights might have silently flickered across the galaxy, waiting for technology advanced enough to finally reveal them. Astrophysicist David Kipping of Columbia University described Proxima Centauri b as exceptionally complex, unlike ordinary rocky planets that merely absorb sunlight and release heat. Instead, this planet demonstrates a peculiar and unusual interaction with its parent star, a phenomenon only visible through JWST's extraordinary sensitivity to infrared wavelengths. Researchers now plan to examine the planet's atmosphere in much greater detail, searching for signs that it might sustain life. The presence of molecules such as oxygen, methane, and water vapor would serve as potential markers of habitability. Although JWST is not perfectly suited to detect free oxygen, it can still identify alternative signals like ozone, which also hint at biological activity. What makes Proxima Centauri b especially intriguing is its location within the habitable zone of its star, a region where liquid water could potentially exist. However, this is not a gentle paradise. Its climate may be extreme, with one side scorched by constant daylight and the other plunged into freezing darkness. Yet even such harsh conditions might still allow life, provided the planet possesses a protective and stabilizing atmosphere. JWST, orbiting far from Earth, can observe this exoplanet every 11.2 Earth days, providing repeated opportunities to capture its atmospheric signals. This is only the beginning. Astronomers are already looking ahead to the next generation of observatories, such as the Extremely Large Telescope, ELT, scheduled to begin operations in 2027. The ELT promises unprecedented clarity and detail, complementing JWST's discoveries and bringing us closer to answering one of humanity's most profound questions. Future telescopes will rely on cutting-edge innovations to overcome one of astronomy's most stubborn obstacles: the overwhelming brightness of stars, which drowns out the faint light reflected by nearby planets. To solve this, scientists are engineering coronagraphs, intricate devices inside telescopes that manipulate light waves to cancel out a star's glare, leaving only the delicate signals of orbiting exoplanets visible. Alongside them, star shades, enormous, flower-like spacecraft stationed tens of thousands of kilometers away from a telescope, are being designed to physically block starlight before it ever reaches the lens. Together, these technologies promise to peel back the blinding veil of starlight, revealing planets that were once hidden in cosmic shadow. With these instruments, astronomers may not only detect exoplanets but directly image them in astonishing detail. Imagine capturing a high-definition image of a distant world and seeing the shimmer of alien oceans, the outline of mountain ranges, or towering weather systems drifting across the sky. Seasonal changes could be tracked over time, just as we study Earth's climate cycles, granting humanity an entirely new perspective on the diversity of planetary environments scattered across the galaxy. The potential discoveries extend far beyond geology or weather. If telescopes reveal specific chemical combinations, oxygen mingled with methane, or water vapor paired with carbon dioxide, these would be powerful biosignatures, chemical clues that life processes are at work. Even more electrifying would be the discovery of technosignatures, patterns of light that suggest cities, atmospheric traces of industrial activity, or consistent radio emissions structured in ways nature alone cannot produce. Such findings would not merely advance science, they would rewrite the very story of human existence. Each improvement in technology pushes us closer to answering the most profound of questions. Are we truly alone, or is life a common thread woven throughout the cosmos? The strange illuminations on Proxima Centauri b may be just the first flicker in a tapestry of discoveries yet to come. If these lights are confirmed as artificial, it would signal not only the presence of life but also the existence of intelligence, civilizations capable of harnessing energy on a scale we can barely imagine. But this journey is not purely scientific, it is profoundly philosophical. To realize that another civilization exists, perhaps older, more advanced, or vastly more powerful, would transform our understanding of ourselves. Would such knowledge inspire unity across Earth, as humanity recognizes its shared destiny among the stars? Or would it provoke fear, rivalry, and competition as nations scramble for advantage in contacting an alien intelligence? The answers are unknowable, but the questions themselves reflect how deeply this discovery would reshape human civilization. The possibilities stretch even further into the future. Astronomers dream of telescopes capable of capturing not only planetary weather patterns but also surface-level features, mapping continents, charting oceans, and even detecting signs of vegetation through subtle shifts in reflected light. Some envision instruments powerful enough to watch the glow of alien auroras, or to monitor volcanic eruptions and storm systems raging across worlds hundreds of trillions of kilometers away. In time, the line between observation and exploration may blur, as these technologies allow humanity to study alien planets almost as though we were orbiting them ourselves. And yet, perhaps the greatest promise lies in the possibility of identifying life in its many forms, from microbial signatures in planetary atmospheres to the dazzling glow of alien megacities lighting up the night side of a distant world. Such discoveries would prove that life is not an accident confined to Earth but a universal phenomenon, arising wherever conditions permit. With JWST as the foundation, and with the extremely large telescope, star shades, coronagraphs, and future space observatories soon to follow, humanity now stands at the brink of revelation. Every faint flicker of light, every subtle chemical signature, could hold the answer to the question that has haunted us for millennia. Perhaps one day soon, we will finally confront the truth. A truth that may comfort us, or forever challenge our understanding of existence. A truth that asks, are we alone in the vast cosmic ocean, or has someone else been out there all along, watching, waiting, and perhaps wondering the same thing about us?